In this video, we will look at the concept of the area under a curve. This is a fundamental concept to integral calculus. So we'll see how this works. Let's consider the function f of x equals x squared. We know that the graph of this function is a parabola like the one shown in the diagram here. And let's say that we want to work the area, or to calculate the area under the curve from x equals 1 to x equals 3. That is from x equals 1, from here, to x equals 3. We want to calculate this area. Now, we may not be able to calculate the exact area using the usual area rules that we know. So since this shape here is not exactly a rectangle or a trapezium or a parallelogram, so instead we try to find an estimate for the area. So what we're going to do is, let's say we decide to divide the area into two smaller areas. And then if I draw a rectangle here, and then a rectangle here, if I find the area of this rectangle and add it to the area of this rectangle, I will be finding an estimate of the area under the curve from 1 to 3. Obviously, you can see that this is an underestimate, since there is still a gap here and here that we are not accounting for. But we'll just go with this for now. So we'll call this the area of lower rectangles, AL, area of lower rectangles, equals. We have two rectangles here, and the area of a rectangle is base times height, and the base here is this length, which is 1 unit, and the height of this rectangle here is the value of the function at 1, so it's f of 1. The area of the next rectangle is base, which is also 1, and the height of the rectangle here is the value of the function at 2, so it's f of 2. So therefore the area equals 1 unit times f of 1, that will give me the first rectangle, plus 1 unit plus f of 2, that will give me the area of the second rectangle. So that's 1 times f of 1. If you substitute 1 into the function, you get 1 squared is 1, plus 1 times sorry, this should be times f of 2, when you substitute 2 into the function, 2 squared is 4. So this would be 1 plus 4 equals 5 units squared. So now the area, the estimate for the area of this here under the curve from 1 to 3 is approximately 5 units squared. Now we're going to repeat the process to find another estimate, but this time we're going to use upper rectangles. So remember, we're trying to find the area from 1 to 3. So I'm still going to divide this into two sections. But then instead of drawing lower rectangles, I'm going to draw the rectangles to go above the curve. So now if I calculate the area of this rectangle and the area of this rectangle here, this is going to give me an overestimate. It's more than what I need because of these extra sections here. The area of a rectangle, base times height, so the base here is still 1 unit, and the height of this first rectangle is f of 2. The area of the second rectangle is base times the height, and the height of this second rectangle here is f of 3. So the area of upper rectangles is equal to 1 times f of 2. This will give the area of the first rectangle, plus 1 times f of 3. That's 1 times f of 2 is 2 squared, that's 4, plus 1 times f of 3 is 9. So that's 4 plus 9 equals 13 units squared. So what we have here is that previously we calculated the area of lower rectangles and it was 5 units squared. We calculated now the area of upper rectangles and it was 13 units squared. So now we can estimate that the actual area of the section under the curve, actual area, should lie between area of the lower rectangles and the area of upper rectangles. So the actual area here is somewhere between 5 units squared and 13 units squared. If you want to get an even more accurate estimate, so the area would be approximately the average between 5 and 13. So it's 5 plus 13 over 2. That's 18 over 2, which is 9 units squared. That's again not the exact area, it's just an average between the area of the lower rectangles and the area of the upper rectangles. Let's now try to improve that estimate that we found for the area under the curve from 1 to 3. Previously we used two rectangles, 2 lower rectangles and 2 upper rectangles. How about this time we use 4? So we are now increasing the number of rectangles. So instead of using 2, I'm going to use 4. So the distance between 1 and 3 here is going to be divided into 4 sections. And this is the first rectangle, second rectangle, the third, and the fourth. So now the area of this rectangle plus this one here, plus this one, and this one should give us an underestimate. It's still an underestimate, it's not the exact area, but notice here that these gaps now are smaller and therefore we're getting closer to the actual area. So now we can say that the area of the lower rectangles equals, now the height of the first rectangle is f of 1. The base now is half a unit, so it's half times f of 1 plus half times, so that second rectangle is still half a unit, the height of the rectangle now is the value of the function at this value of x, which is 1.5, so that's f of 3 over 2 plus half times this one here is f of 2 plus half times that last rectangle here has a height of f of 2.5 or 5 over 2. And then we calculate this. Notice here that you can take the half as a common factor, so that's half times f of 1. When you substitute 1 into the function, you get 1 squared, which is 1, plus f of 3 over 2, 3 over 2 squared, that's 9 over 4, plus f of 2 is 4, plus f of 5 over 2, that's 25 over 4. And then in the end, this should equal to 27 over 4 if you want to leave it in fraction form, or 6.75 units squared. Notice that previously when we used two lower rectangles, the area was 5, but now we're getting 6.75, so it's closer, it's higher than the previous underestimate, and it's closer to the area under the curve. We're going to repeat the process with area of upper rectangles. So you might want to stop the video here and try it yourself and then check your answers. We're still using 4 rectangles. So between 1 and 3, that's at 1 and 3. And we're dividing the area into 4 sections. But this time I'm going to go above the curve to create upper rectangles. So now my aim is to calculate the area of these rectangles. So area of upper rectangles equals half times the first rectangle here has a height of this one here, that's f of 1.5, so that's f of 3 over 2 plus half times the next one is f of 2 plus half times f of 2.5, which is 5 over 2 plus half times f of the last one is f of 3. And again, the half is a common factor. So that's 9 over 4 plus 4 plus 25 over 4 plus 9, which is in the end 10.75 units squared. So now, according to the second estimate, or the second process here, using 4 rectangles, the actual area should be somewhere between 6.75 and 10.75. Now if you find the average here, the area should be equal approximately the average of 10.75 and that is 8.75 units squared. Again, remember from the previous estimates, using two rectangles, we got an average of 9. Now the average here is 8.75. You can now imagine that if we continue on with this process by increasing the number of lower rectangles and upper rectangles, we will get a more accurate estimate until we get very, very close to the actual area. I'm going to increase the number of rectangles, and we'll look at how accurate we can get, but we're not going to do this manually. You can try it yourself, but I'm going to do it quickly using the graphing package to show you what it will look like, and you can check this yourself. So we're still looking at f of x equals x squared and the area under the curve from x equals 1 to x equals 3. So using the graphing package, I've graphed the function y equals x squared. And then to find the area under the curve, I'm going to use this here that's called definite integrals. So if I click on definite integral, and then down the bottom here it says the domain starts from 1. I want it to start from 1 to 3. And I'm going to use 8 rectangles in this time, this process. And I want the area of lower rectangles. So if I get the area, this is what it will look like. That's using 8 rectangles. Notice here that this is now getting even smaller, that these gaps. And the area would be 7.8675. And if I go with the upper rectangles, go area, see that's the difference between the upper rectangles and lower rectangles. The area of upper rectangles is 9.8675. So the area of lower rectangles in this case is 7.6875, and the area of upper rectangles is 9.6875. So again, the actual area should be between the area of the lower rectangles and the area of upper rectangles. The area from these two estimates equal approximately 8.6875 units squared. If you keep increasing the number of rectangles, you will get closer and closer to the actual area, and then in the end, when you calculate the actual area, you should get 8.666 recurring, or in exact form you can write it as a fraction, 26/3, or 8 2/3 units squared. But then calculating the actual area is something that we're going to look at later.